Question 26, worksheet connected particles. A block of mass 80 kg is connected by a light inextensible rope to a block B of mass 40 kg. The rope joining the two blocks is taut and is parallel to the line of the greatest slope of a plane which is inclined at an angle of 20 degrees to the horizontal. The force of magnitude 500 Newton inclined at an angle of 15 degree above the same line of greatest slope acts at A. The block moves up the plane and there is a resistance force of 50 Newtons on B, but no resistance force on A. Find the acceleration of the blocks and the tension in the rope. Okay. So first I'm going to resolve the weights. So there's going to be 40 cos, in fact, 400 cos 20 here and 400 sine 20 here. There's going to be tension here, tension here. Then there's going to be 800 cos 20 here. And in this direction, we'll have 800 sine 20. Also, we have two components of the force, 500 cos 15 and 500 sine 15. And also we have R in this direction and R in this direction. Okay. Is friction mentioned here? Yeah. There's a 50 Newton resistance force is mentioned on B. So on B, there's going to be a 50 Newton force in this direction. Find the acceleration of the block and the tension in the string. So I'm going to form simultaneous equations at A and B. So let's make an equation at B. So at B, forward force is T, my backward force is 50, and 400 sine 20 is equals to M times A, equation 1. Okay, then at A, we have a forward force of 500 cos 15, backward force of T, backward force of 800 sine 20 is equals to MA. Okay. This will give us A equals 0.188 meters per second square and T equals 194 newtons. Okay. You'll solve these on your own and get the value of T in it. Okay, there's also another way of going about this question, which is that you consider this as a single block. Consider the entire system. So now the mass of these two combined would be 120. So you'll have 120 sine 20 here, sorry, cos 20 here, and 120 sine 20 here. Also a 50 Newton pull here, resistance here, and the forward force is this 500 cos 15. The biggest advantage of considering the entire system is that there is no tension here in this figure, and there's an R here, and also a 500 cos 15 component of the force. So yeah, sine 15, sorry. Okay, so now you could just use these forces. Forward minus backward is equals to mass, which is 120 times acceleration, and get acceleration without the need of simultaneous equation. So 500 cos 15 minus 50 minus 120 sine 20 is equals to mass times acceleration will directly give you this acceleration. And then you can use any one of the equations, either this or this, and find tension after that. Anyway, so you could work on simultaneous equations or you could work on the entire system, get acceleration first, and then get tension. Okay, part B says find the time that it takes for the block to reach the speed of 1.2 meters per second from rest. Okay, so for part B, U is 0, V is 1.2, and acceleration is 0.188. So we need to find the time. Okay, we should ideally use the unrounded off value of A, which is 0.18782. Okay, now we need the time. So we'll use V is equals to U plus 80. So 1.2 is equals to 0 plus 0.18782 T. Divide these 1.2 divided by that, which gives 6.3890, which is 6.39 seconds.